Okay, now we're moving into the most advanced statistical method that we will use in this class, multiple regression analysis. And the example that I'm using is I've got a data set that shows, looks like 11, 10, 10 movies, and how much it costs to produce them, how much it costs to promote them, and then if any had books, what their book sales were. So we've got a data set, relatively small data set, and we are going to produce or use multiple regression to determine what, if any, impact these independent variables have on this dependent variables. Can we predict to any degree of certainty, considering total production costs, total promotion costs, and total book sales in millions, can we predict with any degree of certainty how much a movie will make in its first year? And it looks like, according to our model, we will be able to do that with some degree of certainty. And our R-square value here says that our model predicts approximately 97%. 97% of the variance can be predicted using our model, which is a very, very high number, which is great. Our p-values for each one of our independent variables, we've got total production cost p-value of less than 5%. Same for total promotion cost, but book sales not so much. So since book sales, the p-value for book sales is greater than 0.05, we would essentially exclude it and perhaps run the regression again without it to see how production costs and how promotion costs impact our regression. Now, in terms of actually using this data to explain things, our correlation coefficients are actually going to be the most important numbers. And this is really what we were building up to in all of these videos. We understood R-square, we explained p-value, that was created from our t-test. So now we're to the point where we have a set of data and we are attempting to predict the influence of independent variables on our dependent variables, or excuse me, dependent variable. So let me interpret, okay? So total production cost correlation coefficient is 3.662. What that means is for every $1 million spent on production costs, we can expect an extra $3.6 million in first year box office receipts. Okay? Does that make sense? Now, the second one, total promotion costs, what this correlation coefficient tells us is that for every $1 million spent on promotion costs, we can expect an increase of $7.6 million in sales. And there it is. There it is. You know, we have essentially used our understanding of statistics to help predict something from our data set. Okay. Now, what I'm going to do on the multiple regression worksheet is I'm going to show you how to do all that. So in the data tab, data analysis, regression here, we'll click OK. Now we are going to tell Excel, right, where our dependent variable is. That's our y value. And our dependent variable is production costs. Okay, no, sorry about that. Let's scroll over. It is not. Our dependent variable is going to be first year box office receipts. Our independent variables, though, will be these three columns here. Okay, the three columns to the right. We want I'm telling Excel that we are including labels, that our confidence level is 95%. And remember, this is our p-value, which can be as low as 85%, but normally we want to keep it at 95%, which means a p-value of 0.05 or lower. We are going to output all of this right here in cell F1. Actually, cell, we'll see. I think cell F1, but we'll see. So we'll see how this kind of comes out here. All right, everything else looks good. I'll go ahead and click OK, and yeah, it was cell F1. So I can format these to have fewer decimal points, right? Our square value right there. Actually, for these, we probably want just 2 decimal places. And then down here are coefficients. We want to change these probably to 3 decimal places. Okay, so again, there's our square value. Highlight that. Our p-values. Okay, and then of course the numbers that are important to us, that helped us kind of solve this problem. Okay, and that's it. That's a basic multiple regression worksheet.